Okay, we'll continue the topics which we have left in the last class. See, last class we saw the connectivity. Connectivity is nothing but how we connect host to host or how we connect host to storage. And I'll just brief the concept. See here, we use two kinds of things where we use physical components for connecting and we use some of the protocols for connecting. See, physical components, you have host adapters, cables, port. These are all the physical components where you are connecting host to storage. In your syllabus, we have a concept of connecting host to storage itself. Hence, for connecting host to storage, the physical components is your host adapter, cable and your port. And we saw some of the protocols. And protocols here, these protocols helps in connecting from host to storage. We saw two protocols last class. One is IDE, that is Integrated Device Electronics, or it is called Advanced Technology Attachment, ATA. First we'll see what is parallel and then we saw what is serial. The difference of adopting is nothing but parallel is you have multiple tasks running on the multiple channels, but serial is we send the data or transfer the data serially one by one so that in single channel the data is transferred. It all depends on application as I have told in the previous class. One advantage of serial protocols is nothing but the data transfer speed or rate is very high when compared to your parallel protocols. And we saw what is SCSI, that is small computer system interface, and also serial attached small computer system interface. This is also a protocol which is used for connecting host and storage. And here also we see that when you using parallel protocols, the data transfer rate is less when compared to your serial protocol. Hence, based on the application, when there is no demand of parallel protocols, we opt for serial protocols so that we get data transfer rate more when compared to the parallel one. Next is your fiber channel and IP. We will study four protocols here in connectivity. So this is very important question. They ask for define connectivity and explain the communication or connections between the host to storage. And then you need to explain first your components, that is physical components for connecting host to storage, and then explain protocols. And there may be chance of the other type of question like define connectivity and explain the protocols which is used popularly used for connecting host and storage. This may be your 8 marks question. Hence you need to explain four protocols with definition. This is compulsory question and very important question. See, next is your fiber channel, that is FC, fiber channel. This is also a protocol which is used for high speed communication between your host and storage. And also in FC also we have an option of serial data transfer. Here FC is nothing but when you are speaking broadly what is FC, you speak about parallel FC. And in FC also we have a serial data transfer facility where that operates on copper wire or optical fiber. This serial transmission operates on your optical wire or optical fiber or copper wire devices. And also the latest version of FC, that is 16 FC is your latest version FC interface, where the data transmission rate is 16 GB per second. This is the very good speed of transferring the data. As you know, each protocol has its own advantage and disadvantage also. Based on your application and what is your compatibility, you can choose your protocol. And next is your internet protocol, that is your IP. IP. See, IP is nothing also a protocol we transfer host to host traffic is nothing but host to host data. When you want to transfer from host to host, the data transfer is done through this protocol, your internet protocol. And also some of the example of IP is ISC-SI and FCIP protocols. If you mention the examples, it's more than enough. We'll not go in deep because we study only first two protocols in detail, and these two protocols we'll just mention because in SAN platforms we usually use first two protocols. This is about your fiber channel and IP. See, this completes your module 1, chapter 2. We have other concept of, we'll go for chapter 3. You have n number of chapters, but the concepts and the topics are very less, because if you have seen the textbook, they have not followed according to the chapters. They have selected some of the few topics in each chapter and they have clubbed into modules. Next is your module 3. Any doubts in the previous topics? Any doubts? Okay.
No, ma'am.
Okay, next. Okay. Uh, Okay, this is your module 1, chapter 3. Here we study about data protection. For data protection, we'll study RAID, that is RAID, where RAID is defined as redundant array of inexpensive disk. We'll study in detail what is RAID and why it is used when you have n number of devices for storing the data and you have n number of advantages over it. Why we want to choose RAID? As the name itself, topic itself says, the main motto of RAID is your data protection. We'll study in detail why it is required. See, in here we'll study RAID implementation methods, RAID array components, and RAID techniques. See, here in this module, chapter, I'll make it clear that, see, in RAID you have some of these simple problems, very simple problems, just a formula, and where you the data will be given so that you substitute it and find it. This problems we'll do later when you come for offline classes. I'll just cover the theory part now, and we'll brief on theory part and we'll go for the problems later. And for your first internals also, there will not be any problems. Whatever the theory concepts is included, that is more than enough. Anyhow, I'll share the questions for first internals soon. Next is your why RAID. RAID description abbreviation is nothing but redundant arrays of inexpensive disk. See, RAID is nothing but, see, when you when you consider storage, uh, when you're considering a storage, when an organization is having a data center, that is, a data center is nothing but, as you told, it is a facility where you store data, compute it, and you connect it to n number of network devices, and you transfer data, and also you store the data. This is the job of your data center. And we saw what are the components of core components or elements of data center also, like you have application, host, database, storage. Here storage is a very important core component of the data center. And also, see, in previously we had n number of devices for storing data. For example, your tapes, CD or DVDs or discs. You have disk, hard disk, and also you have a you have removable flash memory, flash drive. These are all the things which we used to use before, and even now, based on the things we use it. But what happens is, These are all the devices which we are using for storing the data. And for example, when you consider tapes, tapes are usually used storage option which is used for backup purposes, because for example, now you have drives, the Google Drives. You just drop a document there and it will be stored. But before, when tapes got evolved, the tapes were used for backup things, where when the data will be backed up. But we have a number of disadvantages over that, where the data access is very slow, where when you store the data and when you want to access it, it is very slow and also time consuming. And also when you are storing tapes, data tapes, multiple applications cannot access it at a time. This is the main disadvantage, where tape is nothing but serially you can access, where one application finishes its job, you should wait it, hence it is time consuming. And these are all the things where the limitations came over to the tapes. And also you have an disk storage, where disk storage, for example, you have CD-ROM, joke box, all these storage just with n number of limitations. Then we go for your disk drives. Is one of the where in your PC environment, you're using PC and modern the the thing is, what made changes in adopting to the disk drive is, we have rapid access to the data and also multiple application. Whatever the disadvantages or limitations which we faced in the previous devices, this disk drive came and it eradicated all of the disadvantages, and it gives more compatibility to the application. And when you're using tapes and optical discs, the storage is very less. Storage, it is a small capacity devices, but your disk drive is a large capacity device when you compare. And also, one second. Also, what happened is, it increases the capacity, and also which will enhance your performance also increased when you compare to other devices. And some of the protocols which will support disk drives is your ATA, that is, we have seen advanced ATA devices or IDE devices, and serial IDE and SCSI, SAS, and fiber channel. These are all the protocols which will support the disk drives for the increasing of the performance. This is about the disk drive. When we were speaking about disk drives, we all of a sudden we got the concept of RAID, that is redundant arrays of inexpensive disks. This RAID concept was evolved in 1987 by Patterson and Gibson and Carls. These are the people who introduced the concept of RAID. And first the thing is, they didn't start implementing it, but they wrote a paper. They published a paper on RAID by considering it as a case study for inexpensive disc. That is, they want, the main motto is that you need to do more of the actions, or more of the things should be done with less price. This is the motto of the RAID. And all, what happens is, here RAID is a small capacity inexpensive disk drives, where what happens is, when you have a large capacity, what you'll do is, you will divide this large capacity into small capacity inexpensive disks, and you show it as an logical disks. I'll show in the components how it is uh, implemented. And also you can see that why the disk drives got limitations, and why the RAID concept is that due to mechanical components, the large mechanical components in a disk drive, it offers limited performance. When you have set of previous devices, when the disk drives came, disk drive gave a high performance and everything was advantageous. But when the RAID concept got into the field, then disk drive mechanical components which was evolved, it is a disadvantage or become a limitation for performance factor. In a sense, RAID gives the more performance when compared to your disk drives. And also in the RAID also, what happened is, I'll just show you the diagram. See, this is the RAID, how the RAID is components are divided. See, you have a host. RAID is nothing but it is also a storage component, but it is bit different than the other storage components. You can see host is connected to your RAID array. The overall RAID controllers and all the logical arrays. See, RAID array is nothing but the large data is nothing but your RAID array, and logical array is this data or the disk is divided into n number of small portions, and this we will call it as a logical array. You can see the partitioning of the disk. Here we have mapped 2 disks into one set, and we have mapped 3 disks into other set. For example, RAID array is considering 5 disks, then we have divided this into 2 disks for increasing the performance, and this is called your RAID sets. RAID sets is nothing but we divide larger capacity storage into small RAID sets or logical arrays, so that the access can be done and multiple applications can be used and performance will be increased. And this logical sets and the host is connected with your RAID controller. We'll see what is RAID controller and what it does. This is your overall architecture or how the RAID works. Any doubts? Any doubts? Okay. It is simple. This RAID is nothing but it is a storage medium itself. What it does is the large disks is divided into n number of small disks, and this we will call as RAID sets or logical arrays, and this will be given access for storing the data. And why we came across this is to increase the performance of the application. And you can see here we have a implementation method, RAID implementation method. Here RAID implementation method can be done in 2 ways. One is your hardware RAID and other one is your software RAID implementation. These are all the 2 implementations you can do. Here what is software RAID is nothing but, see here software RAID is nothing but host based software to provide RAID functionality. See here host based software is nothing but this is connecting your host with the OS, and this is related to only the software part of the thing. It is not linked anywhere to your hardware. And one advantage of this software is cost and simplicity, where the functionalities which they're offering is very simple to understand, it is elegant, and also cost of doing it is also is less. And some of the limitations we have for this software RAID, one is performance is low, and also the features which you have or the functionalities which you are providing for software is very less, and
RAID software OS compatibility is sometimes varies, because all application it will not be compatible with these software rates. We'll not study this software or hardware rates in detail, just mention the topic. We'll just see what it is, that's it. This is hardware implementation. The other type of implementation is software implementation.
And it uses specialized hardware controller. As I told, I have shown the controller there, that your hardware controller or controller installed either on the host or on an array. See, sometimes the RAID controller will connect to the host or I have seen in the RAID included in the host. It is same connect both ways so that the functionality doesn't differ, and also you can see the controllers key functions. Why we need controllers? As I told, I'll explain what is controller. See, controllers, why it is important in including in RAID array is that it manages and control disk aggregation. See, manages and control disk aggregation is nothing but it will help in combining when you have large set of data. For choosing disk the combination of disks or aggregating it is helped with your controller. The management and also storing of data and controlling it is done by your controller, and also data regeneration in case of disk failure. See, this acts as a cache also, where cache memory is nothing but the recently having data will be stored there. When you lose the data which is stored in the disk, which cannot be communicated to the host, this RAID controller can regenerate the data so that it can be sent to the host for the service. You can see here you have RAID controller. Here RAID controller job is that to divide this disk and combine it. Aggregate is nothing but you combine it into n number of logical blocks. And the other thing is, whenever the data is when you have a failure of connecting to the disk, or when you have a failure of data is storage, in this kind of things, these RAID controllers will store a part of data, so that this when the host asks request for the data, it can regenerate the data based on the request and it can send back. This is the main thing of advantages of your data, I mean RAID controller. See, this is the how I guess no doubts. Okay. If you get any doubt, you can ask me then and there. Okay, this is how RAID works. All these type questions where you have RAID implementation methods, you don't have any diagrams as such in your syllabus. You should explain RAID or sometimes it is a question. Also, you can just diagram for components. When the RAID array components is asked, you can draw this diagram. See, next is your RAID techniques. See, as I told, the problems we will be seeing in this techniques, but the problems part we'll do later. We'll just see the theory content now. See, the RAID, we have three types of RAID techniques. RAID techniques is nothing but how the RAID can function, do its function in different types of techniques, or what are the functionalities it can offer. See, the three key RAID techniques used for RAID are stripping, mirroring, and parity. These are all the three key techniques. This is compulsory question. They may ask individually. They may do the combination like explain stripping and parity, or explain stripping and mirroring, or mirroring parity, or the direct question like explain key techniques used for RAID. This is 10 marks question for your syllabus. See, for today's class, we'll see what is stripping.
how the stripping works in this, how it gives the RAID a better performance by the technique called stripping. See, in the stripping process, you can see data is distributed across multiple disks and used in parallel. See what happens is,
ಸೀರಿಯಲ್ ನೋಡ್ಬೇಕು ಕೊಟ್ಬಿಡು ಕೊಡು ಹೌದು ಕೊಡು ಇದೇ ನೋಡ್ಬೇಕು ನಾನು ಕೊಟ್ಬಿಡು ನನ್ನ ಕೈಯಲ್ಲಿ ಕೊಡು
Neha, mute the audio.
ಇನ್ನು ನನ್ನ ಹತ್ರ ಇರ್ಬೇಕು ನೀವು
Neha, are you there? Okay.
Controls your overall RAID array. This is your overall RAID array. What we do is each disk into number of strips. You can see here other which is included number of disk which is at the spindle. See, this vertical component is nothing but your spindle, and number of disks you are allocating to the spindle is nothing but strip.
Here you have three disks, so that overall 3 disk set is nothing but your strip, and you have a term called stripe. See, stripe is nothing but it is a combination of number of stripe. I mean strip. All this individual strip, for example, you have 3 strips here, 1, 2 and 3. This becomes a one stripe. This is nothing but set of strip becomes stripe. STRIP is nothing but spindle will allocate number of
Strip. One strip can have n number of disks in it, which is combined with spindle, and you have you can see here. See, you can see here.
This in a spindle 1, 2, 3 disk is your strip process, where set of disks which is located spindle is nothing but strip process, and stripe is nothing but
number of strips becomes your stripe. One stripe. You have 3 strips here. Different disks in each spindle is nothing but your strip. Each is called a strip, and set of all this will be your stripe. That is the concept here, and you can see here you have strip 1, strip 2 and strip 3. We have two disks which is allocated, and all this becomes your stripe, where strip 1, 2, 3 is nothing but stripe. And when you are defining what is a stripe or what is strip, based on your storage, you can allocate it. There is no limitation that you should only use 3 disks for doing strip, or you should only use an n number of strips for creating a stripe. Based on the application you are dealing with, you can do it. And here stripping is nothing but what it happens is data is distributed across multiple disks and used in parallel. See, stripping is nothing but will divide all the large volumes into single disks, and we gather number of disks there, and also this individual disk is used for storing the data. For example, you can see
we want to write string. When you want to store a string like data storage, network and security. You want to store this data storage, network and security. You can see here how it is stored parallelly. Data, storage, network and security. In each strip, the data is stored, and when in accessing also, each strip will retrieve the data to the host. Hence, time is very less, and you can save the data fast, and you can retrieve this data fast. The mechanism is very much improved. This is your stripping process. When it is asked, just define what is stripping, and you need to explain what is strip and what is stripe, and you can explain this diagram also. You can just show how the discs are combined and called strip, and how the strips are combined and called as stripe. You can explain these two figures. So this is the first technique where you divide n number of discs and you store it as store the data serially, not in a single disk, where this in the main advantage of this is nothing but it increase the performance, and it also sees that the time is less consumed for storing or accessing the data. This is the first technique used, and based on the applications you can decide which rate technique to be used. So this is the first process, and you have some of the formulas. I'll explain it later for this. Okay, I'll stop here this process. I'll just play a video for you for better understanding. Give me 2 minutes. I'll just play the video so that it gives a process of how actually the RAID works.
Data storage in these disks is getting faster and reliable with every advancement in technology. However, there is always a risk of data loss due to disk failure. Having redundancy in data storage is an important requirement to avoid any disastrous consequences. To add on to this, as most software applications have to deal with large data files, processing or handling of these files can be slower if these are not stored appropriately and effectively. This will further impact performance of a system. In current video, we will talk about RAID and its usage to achieve reliability and performance in data storage. We will also see how it is used to provide data redundancy to protect data from hard disk failures. RAID stands for Redundant Array of Independent Disk. It is an arrangement of several hard disks acting as a single logical drive for a computer system to provide reliability and performance to data storage. Here, reliability is ensured by preventing data loss by enabling easy and faster recovery of the same. In terms of data storage, performance is considered in form of ability to read and write data to a disk drive. RAID improves storage system performance by serving IOs from multiple disks simultaneously. However, both redundancy and performance are concerns. We need to balance both based on requirement and sensitivity of the system. RAID technology has now grown from theoretical concept to an industry standard and is common implementation into data storage arrays. Traditionally, we can implement RAID using hardware methods. Let's analyze these methods one by one. Soft implementation of RAID is done at operating system and make use of host resources like CPU cycles, memories, etc. It doesn't require a dedicated hardware controller to manage the RAID array. Software RAID is also called as poor man's RAID solution due to its benefits in terms of cost and simple implementation. Administrator needs to play around software settings to manage RAID implementation without paying anything for dedicated hardware. Absence of hardware, on other hand, also limits its implementation in terms of performance, features, and compatibility. Since RAID software consumes host CPU cycles, this may impact complete system performance. Moreover, in case of large data transfers or IOs, performance of storage device is also impacted. Adding to whos, compatibility is another concern with software RAIDs. Since it is an application, it needs to have compatibility with underlying operating system, especially with every patch or upgrades. Hardware RAID uses a specialized hardware controller either on host or on the array. In host-based implementation, controller card is installed on host or on motherboard itself. Disk drive are connected with these controllers. On the other hand, in external array-based implementation, external RAID controller act as interface between host and disk. So, here RAID controller presents storage volume to the host and host manages these volumes as physical drives. A RAID array is an enclosure containing number of disk drives and RAID controller as a supporting hardware. Here, some disks are grouped together to form a logical associations called as logical array or RAID sets or RAID groups. Controller in RAID array provides three main functions. First is management and control of disk aggregation. As RAID controller is an interface connecting host and disk, and physical disks are grouped logical manner in an array, it provides translation of I/O requests between logical disk and physical disks. And lastly, it helps in data regeneration if disk fail based on RAID configuration. Now, how data is regenerated or restored in case of RAID? We will see that in upcoming sections. Now, let's analyze some of the concepts related with RAID techniques which showcase how RAID allow data storage in disk at logical drive. Stripping, mirroring, and parity are few of the common methods. All of them differ with each other in terms of data storage method to provide data performance and redundancy. We will discuss each of them in details to lay down foundation of RAID levels. Stripping is a technique to distribute data across multiple drives and use them in parallel. So during write operation, each disk in an array is broken into units or blocks and data is distributed into these blocks simultaneously. Let a host wants to write a string, data storage network and security. On receiving request, RAID controller distribute each word across drives in array. Similarly, for read operation, each disk contributes in retrieve of data simultaneously and send to controller. We should note that this example is just for sake of understanding stripping concept. We will further look into this concept with granular details. So, as seen in stripping, read heads can work simultaneously. This allows faster processing of data and therefore increase in performance with respect to scenarios where read and write operations are done on a single disk. Now let's have some in-depth detail of how stripping works. Consider a scenario with disk where write comes to a wall. RAID control helps to distribute all data to physical disk. Here, each disk is divided in small blocks, such as block 1 is on disk 1, block 2 on disk 2, block 3 is on disk 3, and so on. Here, as block sequence forms a series of strips across the disk. Hence, this arrangement is referred as stripping. Data is distributed in a strip at a time.
Okay. This video we have what concepts we have and the brief session goes on. So the main thing of trade is nothing but your increasing forms and redundancy. Redundancy is nothing but you have data should be if you have any fails actually. But the stripping is nothing but use example. See here we have a group uh, and this overall is one nothing. All this are strip 1, strip 2, 4, 5 and see here if you want to define what is stripe, you can combination of a number of strips is your stripe. Mind this 1, 2, 3 and stripe 1 combining the and each. As I told, each disk will one data. The thing, for example, this example, if you want to store A, B, C, D till Z, then you can see that in strip 1, it's in strip 1 you have strip 3, 4, 5, and strip 1. The first block of will be stored by that is A. Next, strip 2 that stores D. Serially uses all the number of strips to store the data. First, when you store it in one, processing will become a burden and consuming. Doing all these things, we go for the strip concept. And doubt? Any doubt? Okay, I guess there is no doubt. Okay, once again, I record. What you have, you do your textbook also. I'll share the PPTs and notes, and I'll just share your mod, uh, small questions for internal. So, if you have any doubt, thank you.